Good morning and welcome to today's AWS webinar entitled Journey Through the Cloud Disaster Recovery. My name's Ryan Shuttleworth and I'm going to be your host today for this webinar and take you through the content that we have ready for you. So today's topic is Journey Through the Cloud. And we're going to be talking, the Journey series is around a common set of use cases and stepping stones that our customers use to take their first steps and journey into AWS. So the idea being is that you can learn from their journeys and you can pick up some best practices that might help you to bootstrap your projects in AWS. So today's topic is disaster recovery. And disaster recovery is a perfect use case for exploring AWS in what I call a non-production use case. It's not a front of office, front house transactional system, so you're not having to put AWS systems in the line of fire, so to speak, on your first project. You can explore how you would deploy applications in the cloud that are only used occasionally, or that where you can test how you can use them in the cloud. So it's a great way for phasing systems into live disaster recovery use with relative ease, and you can choose your success objectives around a cloud project out of band because they're not under the pressure of suddenly moving your marketing website straight away into AWS maybe as a first step. So some of the use cases and applications that people move are things that can test out the different strengths of cloud and can test different properties of cloud, and that's what we'll explore today in this webinar. So the agenda, we're going to look at why AWS is a good place to do disaster recovery and talk a little bit about what disaster recovery is and the different ends of the spectrum that you can achieve in AWS. Look at some of the core services that can be employed in a disaster recovery scenario, and look at a couple common DR architectures that people do within AWS. And then I'm going to walk through a end-to-end customer example of how a business has created an entire disaster recovery and business continuity strategy using AWS as the virtual data center underneath that. And then closing off, we'll give you some ideas of where you can go next and find further information. So first off, why AWS for disaster recovery? Well, if you look at some of the people that are doing disaster recovery, they're doing things in very varied ways. So I've got 4 examples of customers that are using AWS as part of their DR strategy. So Sogeti in France are using AWS as a cost-effective backup for their Oracle apps. So being able to plug their Oracle estate into AWS services that enable effective and secure backup of the data behind those applications so they can restore them if required. Sage, there on the right, do their DR and testing environments in AWS so that they can, at a much more cost-effective and efficient way, test their DR on a continual basis and therefore reduce the risk around DR and prove to themselves that they have an overall increased availability of their IT systems. BMC Software are creating backup and disaster recovery systems for remote sales offices so that they can spin up environments that their remote users can log into if required if any back-end services become unavailable in traditional facilities. And Toshiba are storing medical imaging data for long-term storage in AWS, where they have regulatory requirements to keep hold of data for a long time in case they need to restore for audit purposes or that any other source of that data is lost for any disaster reason. So the use cases are varied, and that across those use cases there's a number of business and technical drivers that you may be able to benefit from using AWS in the cloud. So the first is you can typically reduce costs. So you might be able to reduce your DR budget by up to 50%. The rationale goes that if you don't have to have a second physical data center, and that second physical data center doesn't need to be online, then in theory you should be able to halve your DR budgets. You can reduce as part and parcel of that on-premise spend and equipment and all the maintenance and administration that comes with a second set of physical kit to maybe manage load balancers in a second environment, servers in a second environment. And ultimately that leads to consolidating sites, no longer needing to run a secondary site. And some of the technologies or services within AWS really transform the technology platforms you can use. And some of the technologies that are core to disaster recovery, and particularly the backup aspects of disaster recovery, might be tape in your organization today. And some of the AWS services that we'll look at today, S3 and Glassier, can eliminate the need for tape backup. So you can remove an aging technology or technologies with high administrative burdens that come with them. So if you look at DR, and if you like business continuity as a spectrum, disaster recovery is a part of a wider set of policies and controls. So it's also about people, it's about process, it's about how you invoke DR. And if you look at a spectrum, at one end you have high availability, so high availability applications. So you might consider business continuity, a fundamental of it being running your applications in a mode with an architectural setup that keeps them running 24/7, that is highly fault tolerant. And that's at one end, if you like, the hot end of keeping your applications running. At the far right then of that continuity, we have disaster recovery itself, so about getting your applications back or getting your data back after some unforeseen event. Maybe your facilities become inaccessible because of some event in your location. Maybe network connections are dropped or severed to data centers, and you need to recover things. Maybe hardware fails and you have some sort of problem like that and you need to recover data. So disaster recovery at that end. And then in the middle of that sort of spectrum is where you keep your data. So there'll always be a need to back up data, whether you're running a high availability set of applications across a hot environment, or whether you're going to need to recover applications. There'll always be data you need behind it, and backup there sits in the middle. And it's not an all or nothing thing. So I think a common misconception around disaster recovery is that there's a big switch that you pull and suddenly one data center turns off and a second starts up and fires up and takes on the load. It's not actually like that. In reality, you need to choose what needs to fail over and what does not. Some things will be more important to you than others, and some things will still be working. So a classic might be that your internal telephony systems for your offices are working fine, but a core back office system isn't. So you don't need to fail over your entire office infrastructure, you just need to recover a single part of it, the application that your users are trying to use to service your customers. So there'll always be pieces of the puzzle that you might want to fail over independently from others. And the trick is choosing the right strategy for those applications and mixing and matching the approaches so that you have a coherent strategy and you're able to choose with granularity which parts of your strategy you invoke depending upon the conditions. And there's two measures that we use in disaster recovery to classify the types of assets and the requirements that we put around them. And these are recovery time objective and recovery point objective. So RTO, recovery time objective, is all about how quickly you need this asset to be recovered. Is it okay to wait a day to get this application asset back, or actually do you need it 1 minute after it's failed? And then there'll be a sliding scale of times that's acceptable to you for a particular asset. At the other end, the recovery point objective is how fresh the data is that's behind that asset. So you might have a recovery time objective of 1 minute with 0 data loss, or it might be okay that you have a recovery time objective of a day with 30 minutes out of date data. And depending upon the application, it's going to differ. And the balance that you put between RTO and RPO will ultimately define the technical strategy that you put behind that particular application asset. So think about applications on a spectrum of complexity. At the right then, we have these hot configurations with automatic failover. So you might consider that sort of approach for your customer-facing transactional web applications, where you have a very low tolerance to data loss and a very low tolerance to outage. These things need to be running because it's your bread and butter and where you earn money from. At the other end of the spectrum, you might have some back-end reporting system, and that it requires a nightly output of data for a data warehouse to drive the next days of activities. In this case, you've got a more relaxed recovery point objective and recovery time objective. As long as it comes up within, say, 12 hours, and as long as the data is, let's say, not an hour out of date, then you're okay. And in between, you can have different types of applications. So I've got daily scheduled processes and systems getting more intensive. Internal communication systems, you can live with them without them for a little while, but ultimately you need them back up and running as quickly as possible. And again, this spectrum defines the technical complexity, the architectural approach, and the services that you might use in AWS to achieve the recovery of that asset. Now, the fundamental economic model I touched on before about some of those customers that have achieved some of these benefits, but classically, if you're going to do DR, you're going to need a second identical site. You need everything replicated, and if everything has a very low tolerance for data loss or a very low tolerance for recovery time, then ultimately these things are hot. So you'd be running two sites. You'd have in your primary site all your primary routers, firewall configurations, the network is all set up, all your applications and operating systems, virtualized servers, storage arrays, some primary storage and backup and archive systems. And in your secondary site you have the same. Now within AWS, the basic principle goes is that most of that can be turned off or not required in terms of physical kit. And ultimately it could boil down to one thing, which is storing something called a snapshot. So a snapshot to us is a state of a running system that can be stored in our storage platform and then turned on as a running system as required. So simple snapshot storage, and I'll touch on that through some diagram examples a little bit later on, but ultimately the secondary site costs go down. And that's how customers can achieve up to 50% reduction in cost by considering their second data center a virtual data center in AWS and invoking the wake up of systems as required, whether it be for testing your DR processes and business continuity failover plans, or whether it be for doing it for real because something has gone wrong. Now, another thing about AWS and why it's a great platform for doing DR is that often we have a requirement to have extremely geographically diverse storage of information. So if we're in the EU, for example, as our primary systems, of course we have availability zones in a region in AWS that enable you to create segregation between your systems and from a physical basis in terms of power and floodplains and so on. But you might have a requirement, actually, you have a global company and you need to move data out of regions. So if there is a problem in Asia, for example, if you're running out of Tokyo, you might consider running out of Singapore too to store your data so that any sort of very wide regional geographic problems cannot affect you, such as earthquakes or tsunamis. So the broad geographical footprint of AWS serves to create a great backbone for a low-risk DR strategy. And of course, if you're doing DR, then you're probably handling data of sensitive nature and that you're taking your customers' concerns seriously, in which case you need to rely upon some heavy security credentials, and AWS has those. So we have certifications across all those regions that we operate our services from. We have SOC 2, which is a prescriptive industry list of controls and checks that we operate against and are certified against. We have ISO 27001 in these regions, with PCI, DSS for a range of services there, and so on. So you can be sure that we're independently audited. So if you do use AWS as DR backbone for your data, that you can be sure that we're treating it with both physical security in mind, but also around our change management processes, how we decommission storage after it's been used, and so on and so forth, so that you can be sure that the backbone has integrity. Now, you can find out more about that at aws.amazon.com/security, and there's some white papers there that will help you understand the security stance that you can form on top of AWS, which is a key part if you're going to start long-term storing data, for example, for backup and archive in AWS as part of your DR strategy. So what are the services that can be employed? Now, there's a range of them, and not all of them are here. It's not an exhaustive list, but I thought I'd just introduce a few of them that are key that we'll then talk about a little bit more in turn for the remainder of this webinar. So we have object storage and transfer services on the left. We've got some network services and then some foundation services on the right. So starting on the left, a core backbone to many of these DR strategy and architectures is Amazon Simple Storage Service, S3, where you can store objects up to 5 terabytes in size, unlimited number of those objects, and that they're stored with what we call 11 nines of durability. So the system is designed to support the concurrent loss of data in 2 physical facilities. Your data is held in multiple physical facilities in that region, and it's checksummed, and we do all sorts of entropy analysis to make sure that your data in each of those locations is held with integrity. So you can be sure that when you put something in Amazon S3 that you can get it back in the same state as you put it in. So extremely cost effective and a fundamental backbone then to storing objects. any sort of object you like, whether it be files, whether it be binary backup files, whether it be images or snapshots that I mentioned before of running machines. Now another thing that comes into play is how do you get data into the environment to make sure that it's held offsite. So the transfer of data, and there's two services that come into play. AWS Import Export is actually the physical shipping of devices. So if you have very large data sets that you'd like to move into AWS as part of your backup strategy or seeding the cloud system that you're trying to build, you can pack those disk drives into cardboard boxes. You can put them in a FedEx van and we will plug them into the region of your choice and we will load that data up into, say, S3. So extremely high bandwidth compared to maybe sending petabytes over a wire. And then we also have something which I'll touch on later called the AWS Storage Gateway Service. So this is a virtual machine you can install in your data center and effectively mirrors your storage array drives or volumes into AWS so that you can recover them on site or spin them up in the cloud. So I'll touch upon that a little bit later. Now, if you're considering AWS ultimately as a second virtual data center, if you're running traditional systems already, then networking services come into play. So we have AWS Direct Connect, where you can string a dedicated fiber connection from your location to the region of your choice, 1 gig or 10 gig ports, and as many of those as you like. So you can create a private, high bandwidth, consistent latency connection to AWS. This enables you to transfer data, but also it enables you to consider resources that are running in a virtual private cloud, shown there below, to be on your network, because you can extend address ranges into an Amazon VPC, you can define your subnets, and resources in AWS look and feel like they're on your local network. And there are other services as well that help you flip between running production systems in one environment and, let's say, a disaster recovery in another. So Route 53 is a DNS service that enables you to have immediate control over a whole range of advanced DNS topics, running stuff, pointing your web traffic to your local systems versus flipping them immediately to a disaster recovery site in the cloud. Then there's foundation services. So most applications have the requirement for disks, databases, and servers. So we have EC2, Elastic Compute Cloud, where you can create instances, where you can run Windows or Linux distributions. We have Relational Database Service that enables you to run MySQL, Oracle, SQL Server from Microsoft databases. We take care of the management of those, but you can stand them up in the cloud, very cost-effective way of administrating databases. And then we have this Elastic Block Store, which is the virtual disk drive system underneath AWS EC2 instances. And this comes with snapshotting functionality, backupping functionality, cloning functionality. So a great way of effectively virtually unplugging disks or cloning those disks and plugging them into other services. So a couple of those that I've mentioned that are really fundamental are S3 and Elastic Block Store. So I've mentioned S3, but because you can put anything you like in there from 1 byte to 5 terabytes, and it's stored with these 11 nines of durability, and it's hugely scalable. There's unlimited capacity. You don't have to capacity plan around, let's say, a storage area network that you might do traditionally in your own environments, and you have to think about constraints and constantly upgrading that to handle the increasing volume of data that you're trying to back up. S3 takes away that pain and gives you a perfect backbone for storing data and then pulling it back when you need it for some sort of recovery. So whether that just be synchronizing or moving data between two physical sites you have, or whether it being the pivot point for moving data from your traditional facilities to a recovery point in the cloud, S3 is a great place to do that. And then there's Elastic Block Store. So I just mentioned it previously, the virtual disk drives. So these are high-performance block storage devices. You format them up to suit the operating system that you wish to drive from or mount these disks upon. They're 1 gig to 5 terabytes in size, and you're only limited really by the OS distribution you're running for an instance on top about how many of these you might want to attach to an instance. Now EBSs are redundant within an availability zone, so they're already effectively striped within an availability zone, and they come part and parcel with snapshot cloning functionalities. So if, for example, an application fails and the EC2 instance goes wrong for whatever reason, the disk can be cloned, or you can detach that disk from that instance and start a new instance from that volume. And some of the technologies I'll talk you through enable you to create these EBS snapshots automatically from local drives that you have in your SAN, and then recover those locally or back into the cloud. So those networking options that I ran through, looking at those in a bit more detail. So Direct Connect, essentially there are Direct Connect locations around the world that are directly connected for fiber to the Amazon Web Services region. And then from that Direct Connect location, you can work through our partner network to connect up the last mile, so to speak. So you can then choose, depending upon the vendor you choose from, you can have a slice of a 1 gig or 10 gig port, or you can take multiples of those in order to create that secure high bandwidth low latency connection into the cloud. So if you're shipping huge amounts of data, or you've got a lot of physical assets that you wish to then connect to a disaster recovery in the cloud, Direct Connect is the way that I would recommend you go, versus going over public internet. Now of course you can go over public internet, and you can secure public internet with a VPN. So a VPN, effectively you get a hardware endpoint in AWS, and you can download a profile for your piece of hardware, your router configuration, that can then form an IPsec tunnel over that internet. And when I look at one of the case studies at the end of this webinar, we'll look at, so they've used both Direct Connect and VPN in tandem, so they have dual route connectivity to their secondary disaster recovery site. Lastly, VPC, Virtual Private Cloud, and I'd recommend everyone to go this way by default, is where you can take control over the fundamental networking, and you can have private isolated section of AWS logically separated at the networking level from all other users of AWS. And this enables you to define address spaces, subnets, public, private areas. You define NATs, internet gateways, and so on. So if you think that AWS is all about internet-facing systems, well, actually VPC by default would create something that has no internet connectivity. So you could use this, for example, with things like VPNs and Direct Connect in order to create an extension to your corporate network. So you might be running internal SharePoint systems as your disaster recovery application you're wishing to run in AWS, spin it up in a VPC, and it will only ever be accessible from your corporate network. So you can make it and look and feel like an adjunct to your corporate setup. So that's some of the technologies. What are some of the common disaster recovery architectures that people are employing? So there's 4 main patterns. There's backup and restore, where we simply take some data, we hold it in a secure place, and when we need it, we restore from it. There's something called Pilotlight, where we keep a hot data set live. Then we have sort of warm standby, so we're keeping a bare minimum of applications running, maybe with a bit of latency in terms of its data synchronization behind the scenes. And then you have these advanced multi-site solutions where you have AWS and on-premise maybe working in hot modes. Now the complexity of these kind of increases from backup and restore through Pilotlight, through warm standby, to these hot multi-site solutions. But they're all building upon each other, and if you look at backup and restore and Pilotlight, we will ultimately be setting you on the trail of looking at the more advanced ones. So we're going to focus on those first 2 today because of time, and we'll look at backup and restore first. So there's some advantages of backup and restore, and it really boils down to it's not a complex thing to do, so it's really easy to get started, and you can therefore get familiar with some of the services in AWS that are fundamentals to doing pretty much any type of application architecture you wish. So it's a low technical barrier to entry, because really what you're talking about is taking some data and putting it in one of our storage platforms so that you can then recover it later. And you can focus then on incorporating into your cloud, into your DR strategy, not complex technical issues maybe related to running a hot system and so on. And because you're using storage platforms in AWS that are very cost effective, your DR journey starts on a very cost effective basis. S3, for example, those very high levels of data durability come at a very low price. The cost of storing snapshots of, say, a SAN volume in S3 is very cheap. And then you can open up the possibilities of long-term archive and the removal of tape. So you can see how starting at something quite simple, taking a disk snapshot, putting it in S3, can then lead you possibly to the potential of saying, well, I don't need tape anymore because I can then integrate to Glassier. So a classic backup and restore pattern would be you're going to take some backups of your current systems, move them using some tool, and I can talk about some of those in a moment, into S3, and then ultimately when you don't need them very fresh anymore, or the recovery point might be way out in the future, that you move them to long-term storage in archiving Glassier. Now, how you do that is down to you. And you need to think about the process that you put around that, because that's the key to any sort of backup and restore. Because ultimately, you want backups to happen regularly, to be mechanical, and to happen with integrity. And the process you put around it is key to that, because what you don't want to happen is when you recover something that there's nothing there. And that can be quite a common problem in tape, for example, because how do you know the tape was written? But if you put some thought about how you back up and then how you will restore from that archive, and you document those procedures and processes, these technologies like S3 and Glassier really help you with the overall integrity of that process. So I've talked about Glassier, so what is it? It's long-term durable archive. I mentioned S3, and S3 is designed for 11 nines of durability. Well, Glassier is built upon the same kind of platform. So your data in Glassier is held multiple physical disks in multiple locations within a region where you choose to store an archive. And it's extremely cost effective, even more cost effective than S3, because it's built upon the basis that you write it once and read never, or only in an extreme case would you need to pull this back. So typically this is data that ultimately is your only copy. You haven't got multiple redundant copies of this, and that you only ever really need it if some sort of real disaster happens, you need to recover, or maybe some sort of audit event in the future because of some other problem in your business needs to pull that data back. So ultimately it's very cheap for storing, and you only really pay when you start to need to recover that data. Now it works with S3, and this is where your backup and restore and archive strategy can be quite effective. So if you look at sort of a time there on the bottom, and let's take logs as a simple example, and that logs are you're putting those into S3 and making them accessible, and that objects are expired and deleted with a policy that you can apply, a lifecycle policy, on top of S3. So this is all about the simple application of policies through our tool sets. And you can do this through a console, you can do this via our API, you can do it via third-party tools. So expiry of data. But if we're looking at actually some more critical business data that is part of our backup and DR strategy, like transactions, then you might want to make them accessible from S3 for a period of time. So after, let's say, 3 months, you want your critical transaction data that's there ready for very fast access for restoration if you need it, to ultimately move into Glassier, because now you don't have an expectation you're going to need to recover it. Your rolling window of 3 months has moved on. So you can set an automatic transition to Glassier, it will be invoked, and let's say that data then sits there in Glassier for a period of years at a very cost-effective price point. But at some point in the future you need to recover it for audit. You request against Glassier the object restoration, and you say how long you want that to be restored for. Let's say you want it for 48 hours. And it will then be popped back up into S3 after a wait of 3 to 5 hours, and held in something called reduced redundancy storage, RRS, for your period of 48 hours, X hours. So you can then play with that data, do what you need to do, pull it off for S3, and then it'll all be deleted from S3 but stay in Glassier. So this is a classic way of which you can tier the data assets that you're putting into backup and restore, because you don't want everything for all period of time to be held in S3, because you actually want to move to a more cost-effective basis for data that you might need to recover. And that's what Glassier does in combination with S3 and life cycles. So a nice way of handling that sort of life cycle. But the thing to note is that Glassier is a 3 to 5 hour retrieval time. So if you do need to get an archive back, you need to wait that sort of time for it to be brought back into S3 on your behalf, because we assume you won't access it often. If you are accessing these sorts of backups often, then S3 is the place to have them because they're hot and it's very fast. So looking at that visually and how some systems can be put together to do that, this is a diagram where I have a co-location data center, traditional data center on the bottom there, and I've got a classic web app, a web server, an app server, a database server backed by some local storage, and there I've got my website.com DNS. In this case I've got it visualized under Route 53, the DNS service in AWS. And ultimately, you've set up something in this environment to take from your database on a scheduled basis backups and putting them in S3 using a simple put. Maybe this is just a simple cron script taking a SQL backup dump, passing it into S3 with a naming convention and a bucket, and they're all stacking up over time there in an S3 bucket. And then the other thing that you would put into S3, and they're stored here by default, is these things called machine images or snapshots. So AMIs are frozen states of an operating system and underlying disk. So if I were placing 3 AMIs here, one for my database server configuration, one for my app server, one for my web server, and I've got all my database backups in S3, then if something goes wrong, I can do a couple of things. I can recover my database app server and web server from those AMIs and then load the latest snapshot into the database server, and then I can use the DNS of Route 53 to flip my website.com onto my new running in the cloud app stack. Okay, so that in principle is the basis for everything in terms of DR in AWS, and we just add some more sophistication to that with differing services that make that easier. One of those services is AWS Storage Gateway. So Storage Gateway installs in your local environment. So shown on the left is your corporate data center, and on the right is your, let's call it the elastic data center in AWS. And the Storage Gateway gets installed on premise, and ultimately it's there to synchronize local volumes. So under the Storage Gateway, you create some local volumes against your physical hardware that you've got in your environment. And then you can run against those volumes using an iSCSI interface. So classic internal SAN setup, but managed by the Storage Gateway appliance or virtual machine that you're installing inside your environment. And what the Storage Gateway will do running in one of its modes is it will take snapshots compressed and then stored in S3 of those volumes that you have on premise. So let's say you've got 3 1 terabyte disks, you'll be taking a series of snapshots into S3 on a regular basis. So that if anything happens to one of those volumes, you can then go into the Storage Gateway, recover that snapshot from S3 and restore the local volume. Okay? So a simple virtual appliance that enables you to manage local disk. You can also, with a storage appliance, is if you need to, recover that volume into AWS and use it to spin up a virtual instance, an EC2 instance. So if you need to, you can recover locally, but you can also recover into this elastic virtual data center. So just wrapping up some of those things I showed you on a previous diagram in a nice little tool set to help you along the way. Now, Storage Gateway can run in 2 modes as well. So the one I just showed you was Gateway Stored Volumes. So this is where all your data is stored locally. And there's an asynchronous backup process into S3 that are created as EBS snapshots. You get the iSCSI local interface, and each of those volumes can be up to 1 terabyte in size. But you can also run the gateway in what we call a cached volume mode. So this is where actually your data isn't stored locally, but it's stored in S3 as the fundamental storage platform. And you only need a little bit of data storage locally, and that's cached underneath the Storage Gateway appliance. So it's relatively low latency, and you can provide iSCSI local interfaces to your applications in your internal environment, and you can support up to 32 terabyte volumes. Now this is a great way of expanding your local storage footprint without having to buy more storage locally, because you can just simply keep adding volumes virtually to this appliance. They'll be created in S3, and only the regularly accessed data will be stored on, let's say, your couple of terabyte drives that are sitting underneath that appliance. And you might have 32 terabytes of volumes, 32 terabyte volumes, many of them ultimately residing in S3, and we'll work out what data should be local and what shouldn't. So a great way of expanding your storage footprint, but being secure in the knowledge that actually it's running across your virtual data center. There are other appliances as well, not just ours. So I've just talked about the AWS Storage Gateway, but there are many third-party appliances, and at the end of this webinar I'll give you some ideas of companies that have these. You may find that you have some of these backup type appliances already, and they already have an interface to S3, and you can do something like this. So here I've got a corporate data center 2 at the bottom and a corporate data center 1, and ultimately using S3 here as an off-site secure storage dump because this storage appliance is taking copies of local production server systems, moving them into S3, and then synchronizing them to a second data center. So you can use third-party tools in many different sophisticated formats, and often they're using things like S3 or Glassier behind the scenes to achieve the complexity that they're hiding. Another example of just that is if you're running Oracle RMAN back straight up into S3. So a perfect example. So here I've got my corporate data center at the bottom left, and the production apps, and I've got Oracle RMAN being backed up into S3. Also shown on this diagram is our AWS storage gateway, synchronizing some local volumes into S3 as well. So my whole corporate data center, I'm backing up my Oracle apps into S3, and I'm also, all my local disks in that corporate data center are snapshotted into AWS. I've got shown here on this diagram a secure connection between the storage gateway and S3, so I'm implying here that I might have Direct Connect and VPN running. And then over on the right, I've got an Amazon VPC, and I've got my recovery site. This is my virtual recovery site. So I can restore data from those Oracle RMAN snapshots or backups into a virtual Oracle instance. So I'm running that software in AWS on EC2. And I can also restore data that I've done from the storage gateway volumes to create instances such as file servers or my production app servers from those EBS snapshots. And likewise, I can have a secure connection, I can have a VPC gateway, I might have a soft VPN running there, and if my end users need to access that virtual data center, they can, and all their enterprise apps are running in that environment. So layering with sophistication that backup and recovery strategy using some third-party tools, using local tools, and then the backbone of S3, AMIs and snapshots in the middle. Okay. So let's look at a second pattern, which is Pilotlight. So what's the idea behind this? This is all about keeping a core data set synchronized with a local primary site into your secondary site. Because once you've got that, you can build things around it. Because you might build up an environment around, let's say, an Active Directory or a SQL Server database that's key to some sort of application, and you just keep that on, just like the gas Pilotlight. That's the only thing that will be running in your cloud. And when you need to, you can then scale up the resources around that data set to bring up application servers that will be interfacing with that secondary Pilotlight set of data. You can match your current production system scale with resources in AWS through auto-scaling policies, for example. Invoke a scale up and go from 0 servers to 10 to handle a particular load. So ultimately it's about switching over to a system in AWS where the core data you need to run has been kept alive and kept synchronized. So putting back to a diagram like we've seen before, previously in this sort of setup, I had my database server with some sort of job that I'd set up myself, maybe a cron job doing a SQL dump, pushing SQL files into S3. But with this, we're talking about running a Pilotlight, which is that database server in the middle, with some sort of real-time synchronization of my primary database to that secondary. So I might have a synchronous replication operating between the database server in my local facility and the one running in the cloud. And then the resources that I have around it, my web server, my app server, are created but stopped. And when they're stopped, I'm not paying for it. So you can see those stopped instances grayed out. So ultimately, I have a complete replica of my production site, but the only thing that's running is my database server. And I'm keeping that database server backed up, and I've got my AMIs all ready to go, and I've got stopped instances that are configured that I can start very fast if I need to. So if I fail over, then I start those up, click start, and I flip my DNS and I'm running. Then all you need to work out is how you recover back to your primary site, and that's a whole different topic that I'm not going to be covering today. So let me take you through a customer example of how somebody in the real world has put all of that together. So Haven Power is it's the Isle of Wight power company, a utility on the Isle of Wight, and via one of our partners, Smart 421, they were looking to improve their whole DR strategy. So they were a significant business, yet without any really coherent business continuity plan. And part of that business continuity plan was clearly DR for their systems. So they needed an EU DR site for a range of their applications. This has all been set up running inside a virtual private cloud. And this isn't just web-facing systems. This is DR provision for applications that are dependent upon Oracle and SQL Server databases, so heavy-duty enterprise apps. And it includes disaster recovery things like Active Directory and Windows file shares. So a classic, and built over time, heterogeneous enterprise environment. Now their system in AWS looks like this, and I'll talk through in turn the various aspects of it. So in the middle box there is various different aspects of their cloud DR site, and at the top is their 2 data centers that they run currently. Now connecting those things is dual route connectivity. So we've mentioned before Direct Connect and the internet routing, which is your basic route into AWS. So they're running Direct Connect, and they're also running a VPN over internet. So ultimately they have dual route connectivity, so any problems in Direct Connect will fail over to an alternative VPN over internet route. So they can be secure, they've got diverse access to this environment. They're then doing the Pilotlight, and there's a couple of Pilotlights in this environment. The first of those is Active Directory replication. So they have an Active Directory running in a subnet of their VPC, and this is being kept live and hot from their corporate on-premise sites. So that if anything needs to happen, their users can log in, there's authentication services available, and it's up to date. Another thing that they're doing, which is good architectural practice whatever you're doing in AWS, is they're using Bastion hosts. So these are hosts from which, if a ticket gets raised for the administrators and somebody needs to access this environment and do some administrative work, these hosts are then started, and it's these hosts that somebody needs to log on to, and the whole thing's audited. So if you have those requirements, Bastion host is an architectural pattern, and they have these things turned off. So by default, there's no access to this environment unless there's an authorization to start one of those hosts. And they're using things like Smart Sentinel there to ensure that everything's audited and checked. Their second Pilotlight is around their core databases, so Oracle and SQL Server replication. So they've got effectively 3 Pilotlights running: SQL Server, Oracle, and Active Directory. And these things are running all of the time, whereas everything else is effectively turned off. And the other things that they have in there is their application images. So their enterprise apps, their Windows servers, and so on, stored as AMIs in a state which is acceptable in terms of bringing it up and being a running application. They also have remote desktop environments, so they are able to let their remote users access those enterprise apps by remote desktoping in to some of these servers that they start up. The whole thing is then backed by durable data backups into S3. So these Pilotlights are being backed up as well. So if they need to recover anything in the disaster recovery site, they can do from those durable backups in S3. So a backup and recovery pattern playing there as well. Okay, so that really starts to conclude today's webinar, and hopefully that's given you a broad idea of where you can go with DR, but where can you go next to get some more information? Well, firstly, there's a rich partner system. So I mentioned there's some sort of generic storage appliances, and there's many companies out there that are doing that, but there's also many companies that will help you from a consultancy basis to get along this route. So I said before that you probably might have in your enterprise environment a lot of appliances today that already have interfaces that will talk to back-end storage platforms in AWS. And you may also be engaged with some of the consulting companies already, so feel free to reach out via the partner network if you want more information. And you can also start some of these appliances, the virtual ones, through something called the marketplace. So you can go into the AWS marketplace and click launch and launch a completely self-contained, licensed up maybe trial of a particular application or appliance and give it a go, and you only pay for the hour. There's some areas on our website that I'd recommend you go. There's /backup and storage, which is a great area where you'll find a whole host of information on this topic. I would also recommend that you take an RSS feed from aws.typepad.com. If you grab that, that's where my colleagues in the States blog, and any new releases, particularly around things like Storage Gateway, which is evolving fast, you'll get an email in your inbox at the beginning of the day talking about the new features. A great way just for you to keep up on what's being added, because there might be things you're waiting for, and they'll come over time, and that's a great place to get notified from them. And of course, anything to do with storing critical enterprise data in the cloud, you want to understand security. And there's security white papers available, but there's also white papers on the disaster recovery pattern systems itself. So some of the topics that I've covered today, from security through architecture through best practice, you'll find in our /white papers section of our website. So in summary, the cloud makes backup and recovery pretty easy, I would have to say. Using things like S3, using simple APIs or tool sets that you have already available in environments, you can simply take backups and put them in highly durable storage. It costs you pennies per month to get started if you're doing simple use cases like that, and the cloud can scale to accommodate all of your data. You don't need to do capacity planning ever again if you use things like S3 as your fundamental backbone. And ultimately, because AWS meets all those kind of enterprise certifications and you have all fundamental control over your assets, you retain visibility and control of your information. And that's really important generally as part of a business continuity plan. It's all about keeping control of the risk in your environment, and we do everything we can to ensure that you have the tools and the information you need to know that you're retaining control of your assets in a disaster recovery virtual data center. So as ever, find out more at aws.amazon.com, and thank you very much for listening today.